So we have our scale again, and we've got some masses on the left-hand side and some masses on the right-hand side. And we see that our scale is balanced. We have the same total mass on the left-hand side that we have on the right-hand side. Instead of labeling the mystery masses as question mark, I've labeled them all x. And since they all have an x on it, we know that each of these have the same mass. But what I'm curious about is, what is that mass? What is the mass of each of these mystery masses, I guess we could say. And so I'll let you think about that for a second. How would you figure out what the mystery mass, what this x value actually is? How many kilograms is the mass of each of these things? What could you do to either one or both sides of this scale? And I'll give you a few seconds to think about that. So you might be tempted to say, well, if I could end up with just one mystery mass on the left-hand side, then it's going to be equal to, and if I keep my scale balanced, then that thing's going to be equal to whatever I have on the right-hand side. And that part would actually be a true statement. But then to get only one of these mystery masses on the left-hand side, you might say, well, why don't I just remove two of them? You might just say, well, let me do a good color for removing. Why don't I just remove that one and that one? And then I'll just be left with that right over there. But if you just removed these two, then the left-hand side is going to become lighter, or it's going to have a lower mass than the right-hand side. So it's going to move up, and the right-hand side is going to move down. And then you might say, okay, I understand. Whatever I have to do to the left-hand side, I have to do to the right-hand side in order to keep my scale balanced. So you might say, well, why don't I remove two of these mystery masses from the right-hand side? But that's a problem too, because you don't know what this mystery mass is. You could try to remove two from this, but how many of these blocks represent a mystery mass? We actually don't know. But you might then say, well, let's see, I've got three of these things here. If I essentially multiply what I have here by a third, or if I only leave a third of the stuff here, and if I only leave a third of the stuff here, then the scale should be balanced. If this has the same mass, if this has a total mass as this, then 1/3 of this total mass is going to be the same thing as 1/3 of that total mass. So let's just keep only 1/3 of this here. So that's equivalent to multiplying by 1/3. So if we're only going to keep 1/3 there, we're going to be left with only one of the masses. And if we only keep 1/3 here, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 masses. If we multiply this by 1/3, or if we only keep 1/3 of it there, 1/3 times 9 is only 3, or it's 3. So we're going to remove these. And so we have 1/3 of what we originally had on the right-hand side and 1/3 of what we originally had on the left-hand side. And they will be balanced because we took 1/3 of the same total masses. And so what you're left with is just one of these mystery masses, this x thing right over here, whatever x might be, and you have 3 kilograms on the right-hand side. And so you can make the conclusion, and the whole time you kept this thing balanced, that x is equal to 3.